Alright, my name is Jake. I'm the CD captain of drivetrain on Team 1714 More Robotics. And the official definition of drivetrain is anything between the wheels and or the engine and the wheels on a vehicle. But in our case, it's pretty much everything that makes the robot move. So that'd be the wheels, the motors, the chains, sprockets, everything. And as you can see from here, I use this robot as an example because obviously it's clear, and all the drivetrain parts are on the outside of the robot. Now, we probably wouldn't want to do that anymore because if you had to take the side off, all the drivetrain parts would fall out. So, as you can see on this one, can you zoom out a little bit? All the drivetrain parts are contained within the sides of the robot, so everything, like the manipulator, can be put in here. For this year's robot, we had they're called sim motors, which are the motors used for drive. Which I have right here. Thank you. And these are the big drive motors that we use. They're about soda can size, weigh about 2 pounds. And for this year, we decided to use 3 of them, just because it would give us power and acceleration. Now, drivetrain works very closely with chassis because, as you can see, it's very integrated in the chassis. Everything mounts in the chassis, or for this one, the chassis is part of the drivetrain. Now, in the beginning of the season, we don't really get much attention here like chassis, where people just draw wheels on the board to represent the drivetrain. But as the time goes on, we're pretty much the first things that go into the chassis because everything else is mounted over the top of us. So, you go on the side view.
Of course.
And you see for this one, the drivetrain sits very low in the chassis because they're to mount a manipulator on top of it. And also we decided to go with low ground clearance because we had nothing to get over. Now, that was 2 wheels, right, the white ones. Something that we have to kind of go through a drivetrain is when we use new wheels, we never know what's going to happen to the wheels. Now, it originally looked like this one, but then they turned into this one where the robot was actually rubbing on the ground, ripping up the carpet, and we actually bent the screw out of the bottom. That was because we had no idea what these wheels would do because we've never used these kind before. We used 6-inch, but never these 4-inch ones. And also, when you think of a drivetrain, you have to figure out how many wheels you want. Now this year we had a big discussion, 4 or 6. Mitchell had a very lovely half-hour presentation on 6-wheel drive. But for this year we decided to go with 4, which in the end we realized wasn't the best decision because the robot was almost a square. And what happened was the wheels would rub on the ground when they would turn and they'd wear them down. As you can see on this one, we have 6 wheels. And we did that because the robot's longer than it is wide, and it makes it easier to turn because this center wheel is actually dropped a little bit, so it turns on the center. Now, if you've ever seen Rebound Rummer of 2012 robot, we did 4 because that one was wider and it is long, so it turned a lot easier. There are also many different types of drivetrains. There is Mecanum, where the wheels would be, there'd be the wheels, but there'd also be little rollers going at an angle along the wheels. That's an omni wheel. Which you're able to rotate in a circle, you can strafe side to side, you can move any angle you want. There's also omni wheels, which can go to the other robot. 2013, I pulled up on the bottom.
Do you want the rest of it?
I want the whole robot.
Okay. You can have most of it.
Which, omni wheels, which we use on 2013, it's a wheel, but the rollers go perpendicular to the wheel, which allows the wheel to go side to side. Then we just used it on this one, and this robot, the front wheels were driven, but these rear ones weren't, which we thought, well, that's a great idea, it's going to turn very well. Well, as we call it, it's the office chair drive, because what happens was, when you try to turn, the robot would spin really hard, and it was very difficult to turn. And that's because these ones are closer, and these are farther apart. And as you also can see, we have the motors mounted on the front, and that was just to help with the weight of the robot, keep the weight up in the front. Another thing with drivetrain is you cannot be afraid to get dirty. When you're working with the chains, they're always greasy. You're going to be getting grease all over your hands, possibly on your clothes, so you might not want to come here in a button-down shirt and a tie. You also get to learn a lot of tools. You get to work with chassis, where you learn a lot of the tools that they use, and you're also learning drivetrain tools like they have chain brake and stuff like that. once we get everything put in the robot, we keep working with chassis. So, I mean, because we'll have almost nothing else to do except here we had to move the drivetrain from the bottom to the front, which was a pain. But and then once you're done working with chassis, there's not much use to work on the bumpers here. But you get kind of a mix of drivetrain and chassis when you're on drivetrain. Let's see. Oh, you also get to do a lot of metal work because when you're making axles, you get to learn how to use the lathe with Mr. Matthews and you make different axles. You also do a lot of assemblies like this. We have a wheel assembly with a sprocket and a spacer. You also learn what that is if you join drivetrain, which I highly recommend because I think I'm the only one on drivetrain right now. I think that about does it with drivetrain. Are there any questions? Yes, Dave?
Are belts in this team's future?
I've never used a belt. I think we did it 1 year. What a belt is, it pretty much replaces the chain and it makes it for a much smoother, quieter robot. But the issue is you have to make sure it's lined up perfect. Huh?
Got a pulley on the over there.
Oh. Yeah, so there would be a belt, kind of like a treadmill type belt, but obviously a lot smaller. But the issue is you have to get it lined up very precisely, because if you don't, otherwise it's going to be slipping or it'll be too tight and it won't move. So that's why we may want to change. But I think if we have a lot more specific chassis design, we might be able to see belts in our future.
It's all on there. I don't know what you want.
Any other questions? Yes, Mitchell?
What other drivetrain types are there besides a tank drive? I've heard of this thing called a Mechanism
Oh,
drive
yes.
and a swerve drive.
I forgot to get to. We use what's called tank drive, where you have two controllers and you can push them both forward, both sides go forward, back, they both go back. And in order to turn, you would have to turn each side independently, so one will go back, one will go forward. Now with, like Mitchell said, swerve drive, that is an example of a mechanical wheel. As a swerve drive, each wheel has its own little motor, so it's almost like a powered caster wheel, so you're able to do strafing and turning and stuff like that. It is very complicated, and we've never used it on a robot, I don't believe, because we never had any practice with it. So that could be something that we were going to look over that summer, but we never got to that.
That is one that we made as a prototype a long time ago, though.
Oh yeah, that's sitting in the back, broken.
Yeah.
Mitch, I know you're going to ask something that we're going to overcome this year.
How are you going to make drivetrain better?
Definitely looking at not just what everyone wants for drivetrain, but what makes it better. Like for last year, we went with 4, which was probably not the best decision. And also knowing what our materials are going to do. Like we had no idea what these wheels would do, so probably a little more research on the materials that we're going to use.